Thank you very much, Jamie. Nice to see you all yet again, one of the perks of being on the organising committee. So this morning I'm going to be talking about our Alford East Copper-REE Earth project, located in the southern area of the Gawler Craton on the Yorke Peninsula, and in particular our recent collaborative partnership with Fleet Space Technologies. So Thor Energy is focused on uranium and energy metals. I won't be talking about our uranium assets today as they're all in the US, but I'll be focusing on our energy metal or copper-rare earth projects. And we have interest in 3 projects in South Australia. So our Alford East project, and then through 30% equity in Enviro Copper, we have our Alford West and Kapunda projects. These projects are all shallow copper oxide mineralised deposits, 2 different geological provinces, the Adelaide Geosyncline and the Gawler Craton. But what really separates them is we are looking at developing these using low impact, low cost in situ recovery techniques. So in situ recovery, I think most of you will be familiar with the process. It's a much more environmentally friendly alternative to traditional open cut or underground mining. There's no huge open cut, waste dumps, etc. It's really more of a hydrometallurgical process. And here in South Australia, we have 2 operating uranium ISR projects. So we're in the right jurisdiction to, with regulatory systems and experienced personnel to be developing these projects. In the US, there's a few ISR copper projects in Arizona, and I know 1 or 2 that are coming online in Utah and Colorado as well. If you want to know more information about ISR, we have a great explanatory video on our website, so please have a look. ISR, though, ties in nicely with Thor's ESG culture, and particularly our social licence to operate, which is paramount to the success of any project. Having worked on the Yorke Peninsula over 15 years now with different projects and companies, we're competing or perceived to be competing with rich agricultural and farming land, as well as tourism. So it's very important that we work with the communities, so we inform them, we talk about what we're doing, we take them on the journey with us. And we've started that process very early on and started to build some great relationships. The middle image you can see is a drone shot of us recently deploying our ANT survey. And I just wanted to highlight that there's a barley crop, and that shows the level of trust that the landowner has in the work that Thor is doing. Obviously, we try and get to community events such as Pascaville Field Days, local council events, so that we can talk to the broader community about our project, and in particular the ISR side of mining. So the Alford Copper Belt, it's a rather unique banana shape, as I like to call it, semi-coherent zone of oxide copper mineralisation with gold as well as rare earths. These are structurally controlled within deep kaolinised clays and oxidised metasomatite. There's still a little bit of debate around the origins of this, and something that we hope to investigate as we continue to explore the area. The belt itself sort of abuts the Tikara granite on the west and the Wallaroo, Paleoproterozoic Wallaroo group metasediments out to the east, with a few mafic intrusions. The belt, I think, is very much unrecognised as a copper jurisdiction with over 500,000 contained tonnes of copper, and is very underexplored. The image on your right just is a schematic of a Wombat drill hole. Wombat is located down here on Alford West. And what it shows nicely is this deep kaolinised trough. You can see the drill hole went through the normal regolith and then into fresh rock. And then at about 170 metres went back into kaolinised clay for 130 metres or so before going back into fresh rock. This, although is structurally controlled, so it's not nice and smooth like this, this is very typical of the trough throughout the belt. which extends over 50 kilometres. Thin cover, which is great for exploration. We intercepted copper mineralisation at about 6 metres in the Alford East area, and it's a little bit deeper moving south. So we acquired the project in late 2020. There had been a lot of drilling in the area, but it was all targeting deep IOCG, or the next Olympic dam. We used that data to generate an inferred mineral resource of just under 200,000 tonnes of copper. But what we knew is we had to get on the ground and do some drilling to really test the copper oxide mineralisation. So we did a small drilling program just targeting Area 5, so 9 drill holes into that area, intercepting some nice broad copper and rare earth grades. So copper intercepts 73 metres at 1%, 20 metres 2%, and some nice rare earth intercepts, as you can see on the screen. The rare earths themselves sit within the kaolinised clay and are associated with the copper mineralisation. The mineralisation itself is very much controlled by a key structure, and we're now starting to get a bit more of an understanding of that structure. So if we move into the current exploration, so early this year at Alford West, EnviroCopper did a very small ambient noise tomography survey at their Alford Prospect. And when we saw the model that Fleet Space had produced, we were very excited about the way in which it delineated this deep trough that hosts the copper mineralisation. So this led to conversations with Fleet and hence formed a collaborative partnership with Fleet in September this year to undertake surveys as well as modelling the data and incorporating our 3D model into their data sets. So what is ambient noise tomography? This is certainly a question I had to ask myself 6 months ago. It's essentially a process of modelling 2D and 3D seismic ambient noise or passive seismic data. And in our case, we're using Fleet Space Exosphere, which is an advanced seismic array technology. So with Fleet are actually out in the exhibition area. So if you want to know a lot more, I suggest you go and talk to Darren Smith and the team, and they'll be happy to go through it. But basically, using their exosphere, they scan the ground using geodes, listening to the ambient or faint background vibrations, both man-made and natural, so waves, traffic, weather events, and then these are collected in geodes and then in real time transmitted to Fleet's constellation of low orbiting satellites, and this data is then processed and leading to 3D models. It has a very low impact on the ground, but long term it will require a lot less drilling. So the process itself essentially is 5 steps. The first 2 are about collecting the data, the real-time monitoring, and then developing 2D phase maps. These are slices, horizontal slices for each of the seismic frequencies, and then a 3D model, inversion model is generated. And then in our case, we're adding step 6, and that's integrating Thor's 3D geological model into Fleet's, if you like, constraining Fleet's model with real data. So the deployment process itself is very fast and efficient. So we've done 2 surveys over our northern area of the project, each with about 96 geodes. It took about a day to deploy these. The deployment itself, you literally bury the geode about 20 centimetres in the ground, press the button, and then within about 10 to 30 seconds, it flashes green, indicating that it's connected to one of the satellites. You can then log on to your laptop or tablet and see in real time the data that's coming into that geode. The surveys took about 1 to 2 weeks with a spacing of about 120 to 150 metres, giving us a depth of about 500 metres. The technique itself can look down to 2.5 kilometres depending on the spacing of those geodes. So just quickly looking at the data itself. So in our area, most of the noise or vibrations is coming from the southwest, which ties in with the township of Katina, Wallaroo, as well as the Spencer Gulf. Ideally, you would like noise from a lot of different directions, but it also comes down to quality of data, and our data is very clean. Then Fleet have obviously done the phase maps and then created this 3D model. And you can start with seeing with the initial model, oh, wrong button. Some high velocity areas which represent the Tickerra granite and the Wallaroo metasediments, and these low velocity troughs through here, which hopefully represent our deep kaolinised troughs. So the next step is what is exciting, and that's the integration of our data and making it constrained models, shall I say. And this is actually in progress as I speak, but just a few slides just where we're at the moment. This is a 1% overlay on a 107.5 metre depth slice. You can start to see that the copper mineralisation is lying in these deep troughs, also correlating with the key structural controls. If you take off the copper mineralisation, and you can see the underlying image a little bit clearer, again highlighting the structural controls in those low velocity areas. And if we look at the cross section, where we have that mineralisation, you can see these deep troughs over here. But what's most important is just about the 50 metre zone is a little higher velocity anomaly, and that's what we believe is the copper oxide mineralisation. So really excited about starting to see this data coming through, starting to constrain it with our 3D model. So really stay tuned and look forward to having these models out to the market later this year. So just in summary, where we're at, so Fleet will obviously be producing these models for us, generating some drill targets, and we'll be on the ground early next year to drill some of or all of these targets. We'll also be doing some water bores for further pump testing, and we currently have some column test work undergoing, so we hope to have some copper recoveries out to the market before Christmas. And then at Alford West, they'll be doing some passive seismic as well as push-pull testing early in the new year, and working up towards approvals for a site lixiviant trial. And then at the Kapunda project, EnviroCopper are the most advanced in the ISR copper space, and they currently have a lixiviant trial underway. So we should be starting to see some in-ground copper recoveries out to the market early in the new year. So thank you all very much.